Okay, thank you. Can everyone hear me? Okay, okay. So the question that I was trying to address in my thesis is how do we evaluate driving policies? Currently, there's not really a standard for what is considered safe. And I'm also going to take this time to convince you that we need to consider ethics as well. So I am going to start off with an example. So this is a real scenario that happened with a Waymo vehicle. So you can see right here, maybe I'll just go point. So you can see right here, this is the Waymo vehicle driving forwards. And for some reason, maybe it was a drunk driver, we don't really know, but there was another vehicle coming the wrong way down a one-way. And so this vehicle like actually the human driver took over when this happened in real life and swerved and avoided this vehicle. But then Waymo later tried to recreate this crash in their simulation. And when done in simulation, it was found that their policy that they had implemented in this vehicle could not avoid the crash. So it was more focused on maintaining its lane and not swerving and perhaps following a bunch of traffic rules and regulations rather than trying to best avoid collision. So this is one case where the policy may have been considered safe in that it didn't really violate any traffic regulations that we have, but is it really ethical to be navigating the space like this and not avoiding crashes when they are completely avoidable? So that's where ethics comes in. And the claim here is that there's very few, if any, empirical tools to evaluate ethics alongside of safety in autonomous systems. And this problem is focusing on the realm of autonomous vehicles. But this is something that's relevant for any autonomous system, right? That has to operate in safety critical environments. So the contribution that was done here is developing a systematic and mathematical tool to do this for us, where we evaluate safety as well as ethics, and we'll show ways that we quantified all of these regulations and evaluated different path planners against this tool. And also developed a new testing environment on a scenario in which we can evaluate whether a planner is ethical, because right now it's very rare that you will find a situation where accident is unavoidable. So we find a way to create these kinds of scenarios. So firstly, going into the state of the art with how different policies are evaluated, there's a few different publications now that aren't really adapted in industry, but it's something that people use sort of as a benchmark. So first, there's RSS, which is called Responsibility Sensitive Safety. This was developed by Intel, and so it basically gives us 5 rules that we have to follow for essentially utopia to be achieved in which no accidents can happen. And so these 5 rules are maintain a safe longitudinal distance, maintain a safe lateral distance, and don't cut in recklessly, and be cautious in areas of limited vision. And if you can avoid an accident without causing another one, you have to. So some of them are kind of vague, and so we present a new method to formalize them mathematically in like kinematic time constraints. In terms of ethics, there's been a few different ways that people have evaluated ethical decision-making in autonomous systems. First is the moral machine experiment, which is highly theoretical and presents all decision-making as sort of a trolley problem dilemma. So if you know the trolley problem, it's essentially like trolley's going on the path, you can either swerve and kill one person or stay on its path and kill 5. That's kind of the model of thinking for autonomous systems in this case, where we consider all possible decisions and we have some sort of risk assessment of each of the decisions. So the goal for the study is to draw from both of these 2 existing frameworks to develop an evaluation tool that is empirical. So first I'll go into the design of the evaluation tool for safety. So first we take the first 3 rules of RSS because these are the ones that are more concrete. So first we have a distance threshold that we want to maintain from the vehicle in front of us. This is commonly referred to as like the 3-second rule in driving today. Like I think this is sort of a policy that even in human drivers, we try to maintain where you have some sort of velocity that you're going at, and based on your acceleration or your braking acceleration, you have a certain time to collision with the vehicle in front of you. And from this time and your velocity, you can calculate a minimum distance threshold to be maintained. So the way that we quantify violation is by, so in the image, you can see that the violation is determined by the distance by which it exceeds the threshold. Second, the rule was don't cut in recklessly. So we generated costs for maintaining the center of the lane. So you can see, like, if we're serving within the lane, we have like the distance to the center lanelets that were interpolated based off of so the lane of the vehicle is determined by considering all the lanelets in the scenario and determining which one the vehicle has a minimum distance to. And from there, we interpolate a center lane position and determine the distance from the actual path that the vehicle tracked to each center point. And then finally, we also have that we need to give the right of way rather than take the right of way. So this comes into play when we're considering lane changes. So essentially, we need to maintain a speed that is like, we should not exceed the speed of the vehicle next to us by too much. We also shouldn't be braking excessively. So basically what that means is we need to keep a relative speed within a certain threshold from other vehicles when we're performing a lane change. Finally, in terms of ethics, to determine whether we are causing harm or minimizing harm, we first need to define a proxy for harm. So in this case, this is commonly done in literature regarding collisions in autonomous vehicles, but we use kinetic energy transfer as our proxy to the body. So like, we want to determine harm to humans. So for each agent that's in the scenario, we determine the potential harm from the collision that would have been caused by the path that was taken. And then this is determined to be harm. And so there's a few different ethical frameworks that we consider as ways to evaluate different paths. So one ethical framework is consequentialism. So for example, in the trolley problem, this framework would tell us that our actions morality is determined by their consequences rather than the actions in themselves. So if we minimize harm in the end, then that is always considered ethical. So that's why we take the path that minimizes the kinetic energy transfer upon collision if encountered. For utilitarianism, it's a little bit of a stricter constraint where you also have to consider the potential for harm, not just the consequences, because it's not just about the end result. It's about minimizing the overall harm. So we also consider our safety guidelines when we're determining whether a path is considered utilitarian. And so lastly, in deontology, we have certain rules that we follow. And if we are in violation of any of these rules, then our actions cannot be considered ethical. So that's why in this case, we only consider paths that are safe or avoid collision. Otherwise our actions are considered unethical. And that's why in this diagram, you can see like there's a few different possible outcomes. So this is our testing scenario called the dilemma scenario, where basically any action will result in some sort of collision. So the ego vehicle is depicted right here, and you can see like if you trace this scenario back a few time steps, like this car is coming in to make a left turn, and then this one is moving forward with that one on the right. So it's unable to go to the right because it will cause a collision with that vehicle. If it goes to the left, it might collide with the vehicle coming in the oncoming traffic. And then if it goes straight, it will collide with the vehicle that took the left turn. So this is something that was created because the nature of it, like it leads to collision most likely. And so you can kind of see like the like constraints. So like consequentialism is like the broadest of the three, and then we go narrower as we go down the list. So then we defined 3 different path planners that were tested. So in the control, we tested just a regular search, like best first search algorithm that doesn't do any optimizations for safety. It just simply tries to find a path to the goal region. And then we have like a more enhanced version This one will use different heuristics to keep the control inputs in the center of the range to avoid making any rash actions. It's basically so that it has like additional safety characteristics. And then lastly is an even more advanced planner that has online risk assessment of each of the trajectories that it's planning. So the goal for this is to use all of these three planners to validate the tool, because in theory, we should see that our tool is reporting like safer solutions for a more advanced planner. But at the same time, we want to quantify or like characterize the relationship between safety and ethics to see if inherently, if we have some sort of risk assessment, does that mean that the scenarios that we're solving are safer? And also, like, is ethics implicit in safety enhanced planning? So our results for safety are given by this. So you can see like planner 1 and 2 in our qualitative results on the bottom right. So what this is showing is that so this is the longitudinal distance violation here. And you can see that when we're swerving around this vehicle, the path taken is in red. So if we have the safer version is on the right. So you can see that the tool is correctly measuring what it should be. So in here, we have like a much larger distance threshold before we merge around the vehicle. In the second one, you can also see that in order to swerve around the vehicle, we keep a closer distance to the lane to avoid hitting any traffic in the other lane. And then lastly, on the right, we can see that we're actually yielding the right of way rather than taking it from the other agent in the scenario that's yielding into our lane. And then here you can also see like the different solutions to the scenarios. So if a solution is found, it just basically means it reaches the goal region without any collision. So our safer planner is like solving more scenarios like more safely. But in the case of the third planner that was tested, it leaves fewer scenarios unsolved, but it is not able to solve them as safely. So this it implies that there's not really a relationship between ethics and safety. So it's not like implicit in the fact that it's doing some sort of risk minimization, that it will take the safest possible route that doesn't violate all of our safety constraints. And then we go on to our evaluation of ethics using the dilemma scenario and all of our unsolved scenarios. So these are the cases where a collision was encountered, and we're trying to determine whether if a collision is encountered, is it following one or more of these frameworks? So we can see in the third case that there is significant improvement in terms of minimizing the harm, but none of them were able to solve this without collision or without violating any one of our safety constraints. So again, you can see like there are some cases where with safety enhancements, we're able to achieve consequentialist behavior. But in order to have a higher standard of ethics, it needs to be explicitly implemented in the path planner. These are the different solutions to the dilemma scenario based off of the planner. So on the left, we have like a collision because we choose to swerve right. In the middle, we have our safer planner, but it's still unable to avoid a collision, and it tries to abruptly swerve left upon when it encounters a situation. In this one, it was interesting because it was able to assess ahead of time, and so it changed lanes into the left lane, but was still unable to solve the scenario by going to the goal region, but rather stopped in the intersection. But it was able to come up with more creative solutions basically to the dilemma scenario, which indicates like a higher level of reasoning that our tool was able to uncover. So in summary, we proposed an evaluation tool for benchmarking plan scenarios. Rather than having these things like explicitly encoded in a planner, we say that this is a tool to evaluate existing planners, and it incorporates existing standards for evaluating safety and ethics in plat planners. In the future, one thing that we are working on is blame assignment. And so how can we assign blame to different actors in the case that a collision is encountered? And when can we be when can we avoid liability in these cases? And another thing that's being worked on is preventive planning policies. So how do we anticipate these kinds of dilemma scenarios where a collision is unavoidable and then try to avoid them ahead of time? And then lastly, we also can, so a lot of these frameworks are formulated in temporal logic. So that's something that's being considered, is how to then put that into a planner and try to avoid violation of these rules online. So I just wanted to conclude with a quote by Isaac Asimov, that a robot may not harm humanity or by inaction allow humanity to come to harm. And so this was really the overarching goal of this work, to try and ensure that autonomous systems are made to benefit humanity rather than harm them. So with that, I'll take any questions. Yeah, sure.
I'm a little bit confused why the car can't just stop before it's going to the city.
Oh, it's an abrupt cut-in. So like, yeah, also another consideration that I guess I did not mention is there is a trailing vehicle. So we know that it is possible to be rear-ended. That being said, it's not the fault of the ego if it is, but under ethical considerations, like any collision is something that has to be considered. So that's why stopping was difficult.
So
Yeah.
that is supposed to actually go
It prefers whatever causes the least harm. Yeah.
in terms of time.
Yes. Yeah. So yeah, I think that's like a common thing that is done where it always prefers the collision that is not the fault of the ego. But I think that's something that we were explicitly trying to avoid because that's not necessarily moral. Mhm. Yeah. Right.
And so I'm curious if that was anything more kind of if you were to add a static car that you slow down so I slow down, or that like you were trying to give them. So imagine if I was trying to do for offering and an offering simultaneously.
Right.
If I get over and you get over, but my strategy is to slow down and your solutions we are at the company also slow down. Are there some scenarios where there are trade-offs between the ability that makes you safety if you off things like ethics? You would say that like okay, more aggressive because you can see less harm by being more aggressive. Have you thought about how those trade-offs make different ways?
Yeah, so there's a huge debate, and I think really the conversation right now is like how to balance being safe but also being useful. So like one thing about RSS is, so this is not something that I specifically looked into, but previous literature does indicate that with every agent following this framework, then utopia is achieved. And this was, yeah, so this was like research done by NHTSA on like highway driving scenarios. So that's not something that I looked into. That was sort of an assumption that I made in doing this, but definitely like having adversarial agents is an important consideration because again, like this, like I think that in a lot of driving scenarios, we assume the actions of everybody around us and assume that everybody will be acting a certain way, which is not necessarily true. Sure, yeah. Yeah. Yeah, sure. Yeah.
Or like it's like bad, or like it's not so solid, but it's
Yeah.
actually. Have you thought about what added appreciate the safety of the option versus ethics or human ethics rid of that, or is that something that?
Yeah, sure. So first in the actual, yeah, so in the actual planner, so that's the way that planner 3 is actually operating with probabilistic risk assessment. And so that's done online. And so in our tool, we're only looking at everything post hoc. So it's all about like, if a collision is caused, was that the right one to happen? Yeah.